Hello everyone and welcome to another video. My name is Nick and we are doing chemistry, and today we are looking at our dipole-dipole intermolecular forces. So remember, intermolecular forces are between different molecules. So let's look at a dipole-dipole. So a dipole-dipole force is going to be between two polar molecules, meaning two molecules that have different poles. So this would be the positive end of the pole, and then that would then be attracted to the negative end of the other molecule. So there would be two poles, and so these two dipoles, these two polar molecules, attract one another. So this is our first van der Waals force. So this is a van der Waals force, and let's look at water, because water is a special type of dipole molecule. So let's say, well, first, let's give this one an example. So let's call this HCl. So this could be HCl with our chlorine which is, so it's an HCl molecule. The positive side is going to be the hydrogen. This should be a positive here. And the negative side is going to be the chlorine side. And if you look at my other video, I'll put a link on the screen now to why hydrogen is positive and why chlorine is negative. And you can look at your periodic table to see why. So check out that video as well if you are not sure about the polarity and why this HCl molecule is like it is. But we've got the chlorine negative being attracted to the hydrogen side of these two polar molecules. So let's look at a special type of van der Waals forces, a special type of dipole-dipole bonding called hydrogen bonding, which happens between the hydrogen, obviously, and the NOF elements, which are, so let's do the NOF elements, N, O, and F. So if you have hydrogen, it's going to form a hydrogen bond with only these three other elements. Now, fluorine is the most electronegative of the NOF elements. So this is going to have the strongest bond. So what I'm going to do is I'm going to, because it's the strongest bond, I'm going to make that one like that, so that you can see that that will be the strongest of the hydrogen bonds. Then the second strongest, because it's more electronegative than nitrogen, is the oxygen. And then the weakest one is going to be the HN. But now these are all hydrogen bonding, so they're stronger than other dipole-dipole forces. So if you get asked, why does HCl have a, H2S, why does hydrogen sulfide have a lower boiling point than water? You will say because of the hydrogen bonding. So it's stronger, meaning more force is required to break those bonds. So let's look at how hydrogen bonding works. So we'll get our water molecules. And we've got the hydrogen. And so these dipole, remember, they're both polar molecules. So the hydrogen is the plus side, indicated by this symbol here. And we'll just do a couple of them. And our oxygen, which is our negative end. So we'll put that in O. We'll make that negative. And so that's the negative part of the molecule. Okay, I'm going to just do that positive quickly. So this one has got, so this is the positive pole and the negative pole. And what happens with hydrogen bonding is it's a dipole-dipole force where the negative part, the O, is attracted to the positive pole. And so we get this happening where we have the negative and the positive poles of these polar molecules bonding. Now, why is hydrogen bonding stronger than the normal dipole-dipole? Well, because of there can be more of the bonds. So the nitrogen, oxygen, and fluorine can make more of these intermolecular bonds, and so it's going to have require more strength to break the bonds. So this water will, compared to other similar molecules, have a higher boiling point because of the hydrogen bonding. So let's just make a note, hydrogen bonding, and that is the special case of dipole-dipole, but it's still a dipole-dipole bond. It's just called a hydrogen bond. Okay, so hopefully that helps. Next time we will be looking at dipole-induced forces. If it did help you, please find the like and subscribe button and all that good stuff, and share with your friends, and I will see you in the next lesson. So have a great day.